See, dry ammonia, like if we talk about dry ammonia, that means the ammonia which do not contain any moisture. So it is neither acidic nor basic, or we can say it is neutral in nature. I am talking about dry ammonia, keep in mind. I am not talking about the moist ammonia, or I am not talking about the ammonia solution. I am just talking about the dry ammonia. So if you have dry ammonia and you just you can say pour a litmus solution on it, so nothing is going to happen, because dry ammonia is neutral in nature. But you will be curious to know, or you will be surprised to know, that the ammonia actually has a great solubility in water. So what happens when ammonia react with water, it this thing form ammonium hydroxide, which is a weak base. As you can see, it has hydroxide ion. So obviously it means that any substance when dissolved in water, or any substance which contain the hydroxide ion, is just regarded as a base, right? So as you can see that the ammonia carries this hydroxide ion, so that means it is a base. Now the question is that it is a strong base or a weak base, right? Means this means that it is it capable of giving all its hydroxide ions, or it just partially dissociates. So you will be it will be good for you to know that it is a weak base, right? Though it decompose into the you can say dissociate to form ammonium ion and hydroxide ion, but not completely, partially. So we regard it as a weak base. But as far as the solubility of ammonia is concerned, so you should know it is highly soluble in water. This I am just going to explain you the solubility of ammonia on the basis of fountain experiment, right? So I have this in the apparatus here. What is here? We have a round bottom flask, as you can see. It has got a rubber stopper, and here are two holes. One is for the dropper, and the other is a jet pipe which is just going into a beaker which contain the solution. That means you can say that here we have a universal indicator. So I am just telling you that what we are using here, we are actually using here the the red litmus solution, right? So we have red litmus solution, we have the dropper here, and we have a round bottom flask. Now listen to me carefully how we can explain the solubility of ammonia in water. So what we do, we just you can say press this dropper. That means some amount of water just goes into it, the round bottom flask. So when this water from the dropper just goes into the the round bottom flask, so as I told you, ammonia has the greater solubility. So ammonia just dissolve in water and give rise to the ammonium hydroxide, right? So that means when the ammonia which is present in the round bottom flask gets converted into the ammonium hydroxide, not completely but some part, if we say, gets converted into the ammonium hydroxide, that means the pressure inside the round bottom flask is just going to fall, because there is no more ammonia left in the form of gas. It is now converted into form ammonium hydroxide. So what it will do, it will just lower the pressure inside the round bottom flask, but outside the atmospheric pressure is the same. That means the higher if we compare it from the inside and outside. So that higher atmospheric pressure is just going to force this red litmus solution to rise up, and as the you can say the pressure just as the atmospheric pressure is high, so it the solution, the red litmus solution, rises up with the greater force and emerge out as a blue fountain in the round bottom flask, just indicating that yes, the ammonia is being converted into the ammonium hydroxide, and the nature of ammonium hydroxide is thoroughly basic. That is why it converts the red litmus into blue. This I will just show you, as these figures we are unable to see proper coloring. So we see that this color of you can say this fountain is actually made when the red litmus solution is just pulled from the beaker with a great force, and it emerges out to form a blue color fountain. So this is how actually you can explain the solubility of ammonia in water, and also we just prove that what is its nature, because it has turned the red litmus blue, or you can say red litmus solution to blue solution. So this just indicates that it is a characteristic property of base. So obviously ammonia is a base, not ammonia, I must say, it is the ammonium hydroxide. Otherwise dry ammonia is neutral, but whenever you have a wet ammonia, or you have ammonical solution, or anywhere when ammonia is present with the water, right, so it will just behave as a base. That is just indicated by the change in the color of the litmus.